In this video, I'm giving an overview of our work titled Digital Socrates, Evaluating Language Models Through Explanation Critiques. While language models can provide explanations along with their answers, the nature and quality of those explanations are still poorly understood. In response, our goal is to define a detailed way of characterizing the explanation capabilities of modern models, create a sizable human-verified dataset for this task, and train a nuanced interpretable explanation evaluation tool that can generate such characterizations automatically. To achieve this, we first formalize the explanation critiquing task. Given a question along with a model-generated explanation and answer, the task involves giving a critique of the model-generated explanation, comprising 5 parts. The first component of the critique is to identify the most significant flaw, if any, in the explanation, pinpointing which part of the explanation is problematic. Informed by the systematic and disciplined method of Socratic questioning, our critique focuses on flaws along these dimensions, chosen to cover the different types of Socratic questions. The critique also contains general and specific suggestions to ensure that each flaw identified is with a direction for improvement in mind. The general suggestion is a statement that addresses a likely misconception underlying the flaw without giving out the answer to the question. The specific suggestion is a more targeted guide towards the right reasoning chain for this particular question. The explanation critiquing task also involves providing a quantitative metric on explanation quality, on a scale of 0 to 5, with 0 indicating that the explanation is very wrong and 5 being completely correct. We then introduce Digital Socrates Critique Bank, a sizable human-verified dataset for this task. Each instance comprises a question, a model-generated explanation and answer, a critique of the model-generated explanation, as well as any human annotations collected on that instance. DS Critique Bank focuses on questions requiring reasoning, in particular science and common sense reasoning. The explanations are from different models in popular explanation styles. We elicit seed explanation critique data from GPT-4, then perform expert and crowdsourced annotations. To the best of our knowledge, this is the first dataset of its kind on explanation critiquing, covering nuanced and interpretable critiques on different models' explanations and in different explanation styles. We then train open source automatic critique models called Digital Socrates using this data. We fine-tuned 2 critique models, DS7B and DS13B, starting from llama models, using a curriculum of increasing critique quality. We first fine-tuned on silver data from GPT-4, followed by crowdsourced data, and finally expert annotated data. Having defined the explanation critiquing task and gathered a dataset for it, let's look at some insights based on human annotated critique data from our DS Critique Bank. First, we see that explanation critiquing allows us to look beyond accuracy. Even when a model gets the answer correct, its reasoning chain can contain varying degrees of flaws. On the other hand, when a model is incorrect in its answer, it can still make some valid points. Further, we obtain interpretable insights on the different categories of errors in language models' reasoning chains. For instance, when models answer questions correctly, there can still be cases where the reasoning chain has flaws, such as incorrect information. When the model is incorrect, there is a broad spectrum of flaws, such as misunderstanding the question or answer options, incorrect information or reasoning, and reasoning being inconsistent with the given answer. Here is a case study comparing models on science datasets. Looking at the dimensions of explanation flaws tells us that incorrect information is frequent in this model. Localizing the flaws further inform us about topics in which the model has incorrect information. Having a list of such flaws for each model could better facilitate finding problems in models' gaps in knowledge and reasoning. The task also provides general and specific suggestions to correct the flaw, for instance, providing the correct information. The general feedback could then offer directions towards streamlining model improvement or serve as useful retrieval corpus, while the specific feedback helps to correct reasoning for each instance. While explanation critiquing allows for insightful analysis of models, obtaining human annotated explanation critique can be expensive. Fortunately, we can move away from expensive human annotations. Our analysis shows that raw critiques generated by GPT-4 are rated as really good quality to reveal the same trends. Human judgments of GPT-4's critique quality show that most of the critiques are rated as good quality. GPT-4 critiques also agree well with crowdsourced explanation critiquing. In 81% of the critiques, they are along a dimension that overlaps with annotators' identified flaw dimension. 88% of GPT-4 critics give an explanation score of within 1 of that given by annotators on a 6-point scale. What is more exciting is that we can also move away from expensive API calls to query GPT. Our smaller trained models, Digital Socrates, can perform the task of explanation critiquing well too. Based on human judgments of critique quality, the vast majority of critiques generated by our DS models are rated good. For both DS7B and 13B, 84% of the time, the generated critique is along a dimension that overlaps with annotators' identified flaws, comparing favorably to the 81% for GPT-4 critiques. This suggests that our DS models are even more closely aligned to human judgments in terms of identifying the flaw dimension in explanation. The percentage of critiques that give an explanation score of within 1 of that given by annotators is also comparable to that for GPT-4. Using our Digital Socrates models, they can help us reveal various insightful trends on student models. For instance, revealing the trend that when models answer the question incorrectly, in the case of common sense reasoning, student models tend to show a misunderstanding of the question or answer choices, whereas incorrect information is more prevalent as a flaw for science datasets. Our paper provides more analysis on how applying DS on all datasets in DS Critique Bank across student models reveals a rich diversity of behavior. In this work, we defined the new task of explanation critiquing, created a sizable human-verified dataset for this task, trained an open-source critique model using this data. We show how Digital Socrates can, for the first time, provide rich analysis and insights across a range of student models and datasets without relying on unfaithful proxies, expensive API calls, or human annotation. This fills an important gap in evaluation tools for understanding and improving the explanation behavior of models. For more details, please check out our paper.